All right, let's go ahead and tackle this problem here. So this is a trig substitution problem. And the first thing we want to do with the trig substitution is set up a right triangle where the square rooted part, the nasty part, as I call it, goes right here, and x goes right here, and x always goes there. And then what goes over here is the square root of the 4, so 2. Then we want to use our SOH-CAH-TOA rules. So means sine of theta is the opposite over the hypotenuse. So it's the x over 2. Now, from this one, we'll continue with these in a second. From this one, we end up multiplying this 2 so that we get 2 sine theta. Now, if we turn that around, x equals 2 sine theta, this is going to be our substitution. And this is quite often the substitution for these problems. Once you do a few of these, you'll see it's always the same thing. Now, we don't want to stop there. We want to do the cosine of theta, which is the adjacent over the hypotenuse. So it's the adjacent is this square root part. The hypotenuse is 2. When we're dividing by just a number like that, oftentimes it's best to express that as a 1/2 times the square root. Okay, also, we want to solve this equation for theta. So we'll get rid of the 2 by dividing it to the other side, and then we'll take an arc sine of both sides. So arc sine, the purpose of this is essentially to solve for the theta. We have to get rid of the sine part so that we are left with just theta equals arc sine of x over 2. All right, so all of these little pieces we're going to come back to. It's quite a massive scratch work section. And we'll come back and grab various pieces there as we need them. Here we start. We start by plugging in the x equals 2 sine theta in here squared. So it's going to square the 2 and the sine. So we'll have 4 sine squared theta plus 1. On the bottom, inside the square root, there's also a 4 sine squared theta. The dx, it's very important to grab the dx there. A lot of times it'll help cancel things for us. All right, so that's the substitution. Next, usually there's quite a bit of simplification in these problems. So in this particular case, we can see that we can factor out 4 here and then be left with a 1 minus sine squared theta. Okay, here's where you need your trig identity, your Pythagorean identity. So let me go ahead and write all of this other stuff here. So the square root of 4 is 2. Now this is going to be right here, and this is an important part. This piece is you can look up the Pythagorean identity of trig. It's here, I'll just give it to you here. Sine squared plus cosine squared equals 1. If you subtract the sine, you can see that you'll get 1 minus sine theta, and this equals cosine squared theta. So the square root of that is going to be cosine theta. Okay, So here we have a 2 that's going to cancel a 2. A cosine is going to cancel a cosine. So we're going to be left with the integral of 4 sine 2 theta d theta. Okay. Next, whenever you have a sine squared theta, like this piece right here, we're going to replace that using another trig identity called a power reduction formula. And this is something that all of my students have been prepped to understand. This is called the power reduction formula. Okay, it's what's nasty, what's a little bit unpleasant about it is how many little constants and parentheses and everything. But hey, at least we don't have the squared anymore. So let me show you how you tackle this. You have something multiplied here, multiplied with this, multiplied with this. So it actually does not matter which order you multiply these in. This is called the associative property of multiplication. So what we'll do is we'll say, hey, well, this is just 2. And we'll distribute that 2 to the 1 and then to the cosine. Okay. Now, here we're going to finally, after a lot of simplification, integrate. 2 becomes 2 theta. Minus, now when you integrate cosine of 2 theta, it's going to be sine 2 theta. But the thing that happens is if there's ever a number, that number comes underneath to hang out underneath the fraction there. So the 2 is going to come underneath and cancel that 2. So there is just a 1 right here. Okay. Again, these are very involved, but if you study your trig identities, you should be okay here. All right, so here we have an answer, but it's in theta, and we need to convert it back to x. So 2 times theta we saw earlier was arc sine x over 2. So 2 arc sine x over 2. We're trying to get everything back in theta here. This is a double angle, so this thing we need another trig identity, surprisingly. This thing is 2 sine theta cosine theta. So we're going to go ahead and say 2. Now, sine theta is x over 2. We got that from the scratch work. So that's why it's important to study that scratch work so that you can know exactly how to get all of these things. Cosine theta, again, the scratch work says that it equals this. So we're going to plop that in right there. 1/2 square root 4 minus x squared plus c. Okay, so one final little step here. Let's see what I can get here. 2 arc sine x over 2. Now let's see what we have. This 2 cancels that 2. We have minus x over 2 times the rest. Now for some reason, let's see if I made any mistakes here, but for some reason, I'm looking at a solution manual here, and I'm getting a 3 right here. Let's check on this. So this 2 came from right there, which came from right here, which came from this 2. This came from a 4 times a 1/2, which is 2. times a 1. That seems fine. That 4 came from right there. The 1/2 is going to come from the power reduction formula. Let's go back up to see if I somehow messed up here. Let's see. Cancel, cancel. 4. This all looks fine. 4 sine theta. Wait a minute. Where's my +1, guys? Okay. So there's a +1. Let me grab a new color. Okay, interestingly, it looks like my +1 disappeared at some point. This shouldn't be too difficult. Let's see how this works. So really there was a +1 right there. So there was a +1 right here. So 4 times the power reduction formula +1. So ultimately we have 2 minus 2 cosine 2 theta plus 1. So we have 2 theta minus sine 2 theta plus theta, because the 1 integrates to be theta. So the 2 theta plus theta is 3 theta. So instead of 2 times theta, and this piece is theta, I do see now that we were supposed to somehow get the 3 theta there. And my apologies for this little mistake. But hopefully it showed you that kind of a method to go back and check. We all make mistakes in math, and you know, if you do make a mistake, that's unfortunate. You get a couple points off, whatnot. But if you do have the opportunity to go back and kind of check to see where you missed things, it's a good way, the way I showed you, to go back step by step and say, all right, why was this a 3? Go back step by step, all the way. Turns out I had to go all the way to the very top because I made a boneheaded move of just not putting the +1, and then follow it through all the way. And if it gets too messy, just rewrite the problem. I'm not going to rewrite this problem, maybe in the future, but I'll leave the video as is. The answer is 3 arc sine x over 2 minus x over 2 square root 4 minus x squared plus c.